So this is the Higher Triple 2020 paper. So the first question is a nice ionic bonding question. You have to identify two errors with the student's answer. The first one is that should be positive. The second one then is that should just be 28, not 288. Okay, so that's the first part. Name the type of bonding present in potassium fluoride. It is ionic. Then there were a series of pictures and they asked you to look at which one represent potassium fluoride, and it's going to be C. Okay, that's going to be some sort of simple covalent bond. That's a metal, and that looks like graphene potentially, but I could be wrong. It doesn't look like graphite because it's not got the layers. Then it says to do the electron structure of fluorine, so two of them. You'll have two molecules where they'll share two electrons. Name the raw material X. That's going to be air. We take the nitrogen from the air. Temperature and pressure is used at 200 atmospheres. State why higher pressure is not used. Could explode and it's more expensive. Use the substance used to speed up chemical reaction. That's a catalyst. And then it told you made two ammonia molecules. You got to use these to make two ammonia molecules. That was actually a really easy question for 2 marks. Give the letter fertilised with ammonium sulfate. Really nice and easy to find ammonia. It's always the litmus paper and it turns red to blue. Okay, sulfate then is barium chloride. That would be chloride. And that would also be chloride, and that would be potassium. Then how many chlorines were on this side? So you had 6 on this side. 3 times 2 would be 6. So you need to put 6 in front of there. Give the name method used to extract aluminium. That's electrolysis. What's going on in this diagram? Okay, so tin had the oxygen. Tin got the oxygen taken away from it by carbon, so tin has been reduced. Nice kind of question to pick up some marks here. This is top, swap, drop twice. Okay, so top, swap, drop twice. Okay, just using a table of ions. And then you've got 3 coppers on this side, so you need 3 coppers on this side. Put the metals in order of reactivity. This was quite complicated for 2 marks. Okay, so look at the first one. A reduces oxide C. So A is more reactive than C. Okay, B reduces oxide A. So that means B is more reactive than C. Okay, so if we're doing this, B, A, C. Okay, B reduces the oxide of C, which is fine, and then D reduces the oxide of B. Okay, so D is the most reactive. So that's how I came up with it. There's a lot of thinking for 2 marks there. Nice, easy question then. Calculate energy needed to break 1 OH bond. So it told you that the 4 of them were that. Divide your number by 4, gives you that number. Okay. Then it says calculate energy released when making 1 of the O bonds. Okay. You are told that 2 of them for the hydrogen is 436. Take it away from that number, so that gives you that number for the O double bond. So in this diagram then it says to show the overall energy change. That's always the difference between the reactant and product. So then it's asking us to work out what's going on in each of these stages. So yeast is added to glucose, so that's fermentation. Unreacted yeast is removed, so that's a filtration, removing that unreacted yeast. And then ethanol is separated by solution, use distillation to separate. Recognise ethanol, it's that one. Okay, that's the test for ethanol, and the colour changes there. That's nice, 2 marks there. Then it says the peak that would represent alcohol, that's the OH bond. What letter is the OH bond? 2,500 to 3,500. So we're looking at that one there, so A. Give the letter of the peak that we use to distinguish ethanoic acid from ethanol. So you're looking for the bond that gives you the OH. I lie, the C double bond O. That's that one, so it will be F. Give 1 health problem associated with alcohol abuse over a long period of time. Liver disease. Give 1 problem associated with exercise. Excessive intake of alcohol. Binge drinking during the evening. Fights. Blackouts. Name process A. So process A is the process of breaking down docdectane into smaller molecules. So that would be cracking. These are questions then. You've got 12 carbons on this side. So you need to add these numbers up to make sure you get 12. Okay, the same with the hydrogens. It's all about making sure you've got the one on the side. The third isomer is methylpropene. Draw the structure. So propene's 3 carbons. Draw out the main bulk of it with its double bond. Methyl group is then a CH3 group. Repeating unit, so remove the double bond, stretch it out. Sometimes they ask you to put an N, so be careful of that. Then it asks you to do what would happen if you added Br over the double bond. They kind of helped you out there by giving you a bit of a structure. And then you put 2 Brs there. And then put a tick next to the name of the product. So it's 1,2-bromoethane. Because there's one on that carbon, one on that carbon. Apart from landfills, give another disposal method for the general household waste, state an environmental problem associated with this method. So you can burn it. Burning plastic releases toxic fumes. What is the raw material of making plastics? Okay, so plastics start as crude oil. And then you separate them using fractional distillation. Fractional distillation makes loads of long chain ones that aren't as useful. We separate them long chain ones using cracking. Okay, and then if you're going to make a plastic, use polymerization. So it is quite a long and drawn out process, but its starting point is crude oil. Blank page. Lots of information here to read. Okay, I'm not going to read it to you, but lots of information here to read. Focus on this, like the bulk gold, gold nanoparticles, things like that. So the first question says, put statement next to 2 statements which support the opinion that the new method is more environmentally friendly. Okay, uses less energy and reduces carbon dioxide emissions. Converting methane to methanol. Okay, add the oxygen on, and you get 2 methanols. The melting point of gold, okay, again, take a true statement. If you read the information, these 3 are false. That is the only true statement. Okay, so lots of information here looking at burning ethanol. They gave you the mass of ethanol and they've given you the heat given out. First thing you have to do is plot a graph, okay, that then should be a line of best fit through it, okay, so that gives you 3 marks by here. Okay, so the temperature rise can be calculated using the formula below. Energy given out is 4 times the temperature rise times by the mass of water. Okay, the mass of water is 250, that's found on the previous page. Okay, they tell you the energy given out by student D was 8.4, so they told you that. The value we didn't have was the temperature rise. Okay, so you have to rearrange the equation. You ended up with this. Okay, and then we have to make sure we times it by 4 because of the units that we used for the energy change. Describe the relationship between the mass of ethanol boiled and the energy given out. The mass doubles, the energy doubles. Give one a piece of advice you would give a student to resolve this problem. Use a lid, insulate the beaker, reduce heat loss to the surroundings. Another blank page. Okay, so this is looking at transition metals, and a series of reactions were carried out between Fe2 plus and Fe3 plus. Okay, it's a big property of transition metals, being able to have 2 different ions. Okay, so looking at the reaction, what expected would you see to happen to iron? Iron should turn from a blue solution to an orange. Okay, when you see iron, it kind of looks like it's rust. Okay, balance the equation. So iron reacts with iron 3 chloride to make iron 2 chloride. Okay, so you had to use top swap drop again. Can you see how common top swap drop is? Okay, to create that, which would have given you 1 mark, and then balance it out because you technically had 3 ions on this side, so you need 3 ions on that side. Explain the meaning of the term oxidation in relation to reaction 2. Oxidation is the loss of electrons, and then I've given you a little bit of an equation to show that it's losing electrons. It's lost 2 electrons. Name the reagent to identify copper ions. I would use sodium hydroxide. And a blue precipitate should form. Right, last question then, looking at mole. So the first bit, you're asking to work out the number of moles using this equation. You had to rearrange it so it's concentration times volume, but we know that N equals C times V. Okay, they gave you C to be 1.5, they gave you V to be 12, divide that by 1,000, times them together, and you should have ended up with that value by here. Okay, calculate the number of moles in ammonia. Ammonia is by here, so it's a ratio of 2 to 1. So we've got 1 of them, so times it by 2 to get the moles in ammonia. Okay, calculate the concentration of ammonia. We know the moles, we know the volume. The volume is up here. Okay, we know the volume of ammonia. So then we do the moles that we've just worked out by here, divided by the volume. Make sure you're still dividing by 1,000, and that would give you a concentration of 3.6. Okay, tough to get all the way down, but it is nice marks if you get there. Then it says, predict the temperature of dilute ethanoic acid added to sodium hydroxide instead of dilute hydrochloric acid. Temperature change would be lower. Ethanoic acid is a weak acid. Name the salt. So it would be copper ethanoate, and this would be its formula. Okay, the reason for that is that copper is Cu2+. Again, it's just a top, swap, drop. And then the last question was a 6 marker. Lots going on with the 6 marker. Okay. So the first thing you need to divide and conquer is the fact that there's 2 positives and they're attracted to the negative electrode, okay? The H plus ions move to the cathode and gain electrons, so I've given a chemical equation for that and I've called it reduction, okay? The reason for this, that's a big reason, is that hydrogen is less reactive than sodium, so move on to the cathode. Again, you've got 2 negatives, they're both attracted to the positive. It's the chlorine that's going to lose electrons to form chlorine gas. OH ions less easily oxidized than chlorine, so remains in solution. Okay, the Na plus and the OH will remain in solution and make sodium hydroxide. Lots of extra space if you need it. More extra space. And then you've got table of ions. This is so important. You've noticed how many times I've said top, swap, drop? So many times, because it's so important to use that in your periodic table as well.